Hi, I am Aryan. I work as a security engineer at Blue Flag Security. This is a talk on PostgreSQL security, but the goal over here is to help you understand the fundamentals or the fundamental pillars of security, how exactly you should approach security in your database. So before I start with talking about PostgreSQL security, I want you to understand why exactly it's important, what are the things you should be looking at, and what's the right mindset for adding security. So first, recently you would have heard of DeepSeek. What happened is that DeepSeek had a database, it was ClickHouse, and turned out that ClickHouse database was already available on internet. It was exposed on internet and it had around 1 million logs that showed what kind of queries were being made, who were the users, and a lot of sensitive data. There were the API keys as well. And that became a huge problem because everyone who was using PostgreSQL had some kind of trust. Every user who was using DeepSeek had some kind of trust issues after this. But these are the kind of things that every now and then happen. You have to be careful about how you're going to set up your database, and not just that, you also have to think about what are the different parameters or boundaries that are established when you're setting up your database. It's not just your DB, it's also the other things. So the agenda for the talk, first thing I'm going to talk about for fundamentals of database security. Over here I'm going to talk about what exactly is the cost of adding security, what are the kind of challenges you're going to face when you're implementing security in your applications. What is CIA trial? It's a model that we use, and how exactly do we go about threat modeling this? Then I'm going to talk about some features in PostgreSQL that are around authentication, authorization. There is no feature around auditing that I've added, but I've already mentioned it here. Then some interesting extensions that you can use to improve your database security or the security of the data present in your database. And then a couple of best practices. Now, a disclaimer, I have only been looking at PostgreSQL for the last 2 months. I'm not really going to claim I'm an expert here. I have learned some things, but this is a very theoretical talk. You won't really see a lot of implementations or hands-on knowledge here. But the things that I'm going to talk about I'm hoping that they'll be useful for you to help understand how exactly you can approach securing something, not just a database. So, the security challenge. Now, the reason I'm mentioning it as a security challenge is that this is the kind of challenge that we face anytime we have to work with engineers. The first problem, usability versus security. You can't just go about enabling all security features. That is not exactly a good idea. You have to come across a reasonable level of security that is acceptable for you. There will be some risk, but you have to figure out what exactly is the most acceptable risk for you. And the reason for this is the moment you start implementing security, you take a significant downgrade in the performance of your application, especially when you go all max on the security levels, or if you say, okay, I'm not going to implement any security. That's a bigger issue. So yeah, applications need fast access. It's not like all the users are going to need the same permission levels. What's going to happen is, let's say you're a manager and you don't want other managers to change your employee data, right? So you have to keep these things in mind. Then you have to think about damage containment. So this is coming in from one of the first security courses I had in my college. My professor mentioned something around why is it important to prevent further damage. So one of the first lessons for me was, if let's say there is a damage has already occurred, you need to be in a state where you can actually prevent further damage from happening. So let's say your operating system has already been compromised. How can you prevent your database? How can you prevent your data from being leaked, even with a compromised server? These kind of things become very important, because if you don't want just one place where if particular place goes down, everything else goes down. The next thing is defense in depth. As I mentioned earlier, there are different parameters or boundaries when you start thinking about security. It's not just a database. This is something I'm going to talk about in a later slide. So, yeah. Now I'm going to talk about the trade-off you have when you're implementing security. First one, which is something I mentioned earlier, performance. The moment you start looking at implementing security or maybe just adding simple encryption, there is some kind of overhead that comes up. Sometimes it's very simple, sometimes it's very minimal, probably 1 millisecond or something. But once you start looking at it at scale, suddenly things start adding up. And that is when people are not exactly too happy with implementing security. Play simple encryption, it's not exactly a lot, but then you start looking at more complex things like implementing row level security checks. Now things can go slow, especially with more complex queries. And then if you're going to say, hey, how about I just upgrade my machine, because an upgraded machine is obviously faster. Not always, because there's always a limit on how many times you can upgrade your machine. Otherwise what's going to happen is it's going to have a very high cost. So you can't just say I'm gonna implement everything, as I said earlier. Now the next thing, engineering productivity. And this is a challenge that I had been facing in my first job as well. Anytime we had to go talk to engineers, and I would say, hey, you need to fix this particular thing, it's a huge problem. They always had the same thing to answer. This security thing is your job, it's not my job. So if, let's say, I start working on what you're telling me to work on, what's going to happen is my task will remain incomplete. So I'm not going to do it straight up. And this has always been a challenge. Anytime I talk to a security engineer, they have been telling me the same thing. Engineering teams generally don't agree. And this is why they generally tend to stay away from security teams as well. But the problem is, if you have to implement security, you need to talk to engineering folks as well. Everyone needs to be on the same page. Anytime you add a security review or you are saying, hey, I'm going to do some kind of security testing here, it takes some time in the sprint, which means they don't have enough time to either build the application, build that feature that they're working on, or the product that feature that they have to deploy is going to be a little slow. The sprint time is going to increase, or the expected time by which they have to deploy this particular feature is going to increase. So not everyone is going to be happy about it. Then the next part, once you start looking at adding security checks, it increases complexity of your applications as well. If you have been building applications, just adding simple login and logout page can be a little complex. And this is why people are not exactly too inclined on implementing security checks. But then comes the operational aspects of things as well. It's not just that engineering productivity that's a problem. If you start looking at operation side of things, what's going to happen is you need to conduct your security audits regularly, especially if you're a fintech or a healthcare application, you need to do those things. And it's not just that you're going to do your security audit, it's all done. What can happen is employees are coming, employees are leaving. So the same permissions that were applicable earlier are not the same, or maybe your organization went through a restructuring. So the people who had access to a particular database earlier, they don't really need that access. Do you allow them to access it? That's something that people have to think about. Generally, it's better that if you are changing your team, or if something, or if you're leaving the company, your permissions should get revoked. So access control maintenance is another overhead that people have to bear with. Then patch management. Your operating system needs to get updated regularly. You need to update your database as well. And with all of this comes another cost, the money side of things and the labor side of things. If you are thinking about doing all of these operations, or you are setting up this encryption and whatever, there are people who need to review all of those things. What's going to happen is that you'll need more people in the company. And because you need more people in the company, it's going to have a significant cost because you have to pay them salaries. So this is why implementation of security has been harder. It has been quite hard. Yeah, you don't have to just think about productivity or time, you also have to think about the cost. And the trade-off is, if it ever so happens that you were breached because you did not really implement security the right manner, you'll have to pay huge amount of fines, especially if you're a fintech or you're dealing with any kind of sensitive information. So the next slide, CIA triad. CIA triad is a model that we use when we have to think about securing applications. This is not perfect, but it gives us a good starting point. So we start talking about confidentiality, integrity, and availability. Confidentiality, it says that only the people who are supposed to access something should access it. So how do you, so another way of saying it is, people who are not authorized to access some kind of data should not get access to it. How do you prevent it? There are different ways. You think about encryption, you think about access control, you think about masking your data, or you look at views. Integrity. Integrity says, integrity is basically a guarantee that the data that you have, the data that is being received or the data that is stored is actually accurate. And this is a very hard challenge. It's very hard to implement in terms of engineering, but people have already done this. There are different ways of implementing integrity. One of them is using transactions. If you have if there are multiple transactions happening, if there are multiple users trying to access the same data or modifying the same data, how do you ensure that the data is in the right manner? You use transactions, you look at validation, constraints check, and you also start looking at tracking your changes. Because in case something has already gone wrong, you also need to figure out what exactly went wrong, who did that, all those things. The next part, availability. Availability means the data that the people who are supposed to access data should get that data. And this is, you can also think about it in terms of software reliability, where you have to make your data, where the people, where your clients should have access to the application as and when needed. This is pretty much the same thing as I see it. You have to ensure that your system has a good uptime. How do you do that? You think around database replication, you look at connection pooling, you also start looking at things like backup and recovery. Because in case something is going wrong, you also need to recover your instance pretty quickly so that the operations are up and running as quick as possible. Then you start looking at resource management or query optimization, because both of them have an impact on the performance of your applications. Now, the threat model. So, threat model is one of the first steps we take when we start thinking about our applications. And anytime you have to work on any of your tool, maybe you're working on your PostgreSQL instance, or maybe you're looking at something else, the first thing you should think about is what exactly is going on. And you need to have a bird's eye view, and you also need to think about what exactly is going on in the internals of your application. So this is just the bird's eye view, where users are using an application, they are trying to access the server. They're using that application to access some data that's present on the database server. You can think of it as cloud, or maybe it's the server. It doesn't matter that the data center is in your office premise or your cloud or your AWS data center. The idea is the same. User makes a request to the application on internet. That application makes another request on this application makes a request to its backend server. This backend server is what is going to make request to the server. Now, this backend and database are hopefully in the same server. Sometimes they might not be, especially when you're looking at cases like MongoDB Atlas or something else. And then there is a machine in that data center that actually hosts your database instance. In this case, it's going to be PostgreSQL. Now, this PostgreSQL is going to make requests to that data which is present on the file system. So suddenly, the one thing that you were looking at was database. But now, if you start thinking at a high level, what's going to happen is that there are too many parameters, and you have to think about securing every single part over here. It's not just the user, not just this network or the application, not just the database, it's also the file system and the host. Now, once you have thought of the different all the different things that are happening, you start thinking about where exactly can the things go wrong. Now, I'm going to take a very weird example, but it is something that companies actually plan for: natural disasters. In case there's an earthquake or there was a tsunami, your servers can go down. How exactly do you ensure that you still have your data? So here are some of the attacks or potential problems that can happen with your database. And do keep in mind that it's not just the database that's risky. It's also the data that's being received by the database that can pose threats. Most of the attacks that you're going to see are not related to a problem in PostgreSQL. They are just requests coming into PostgreSQL. So once you start looking at users, they can go ahead and send you malicious requests. What they can do is they can malform the data so that they can extract more information than they should. Now, this request is being sent through a network, right? As I said, internet. What if that network was not secure? This was something that people used to face 20 years back. Not really the case anymore because everyone is using HTTPS. But still a possibility in case you're using your corporate networks. So over here, what if someone is eavesdropping? They can find out what exactly you had been doing all this while, or what kind of data had you sent, what kind of data you had received. If you are using your credit card information, you are in a huge problem. Then your application might have some kind of misconfigurations, and that misconfiguration could send some bad data over here, and then that bad data gets propagated to the file system, so things get corrupted. But not just that. If you look at the data center, what if an employee of your company or an employee in that data center has had a bad day, and they decide they're going to ruin everything for the company. They took a hammer, they started crushing the servers. Another thing that can happen, although it doesn't generally happen. Now, if let's say an employee just walked away with the server, how can you ensure that they still don't get access to all that confidential information that was present in the database? There are ways to prevent those things. For example, you can look at encrypting your data not just in transit. Transit is when it's coming from user to the server. You also have to think about how exactly you can encrypt data that's already present in the file system, which is present in your host, the server machine. Now, there is another attack. What if your machine has been compromised and someone is trying to access the files present? It's trying to access the write-ahead log, or maybe it's looking at temporary files that get exposed. The amount or the time that those temporary files get exposed for is very small. But in case there's a good hacker present out there, and the machine, they already have access to the machine, they could pretty much go ahead and look at that sensitive data, even if you have set up encryption over here. So these are the kind of things that start coming up. Sometimes, as I said, DeepSeek had already exposed their ports on internet, so people could access that database, you could write their queries. It's not exactly a case in PostgreSQL, but sometimes if you somehow could access or tamper the audit trail, that's even bigger issue. And every now and then, what you're going to notice is that people miss logging their data as well. So if you did not log in the data, no one really knows what exactly happened to that data. So this is about the threat model. Once you start thinking about the threat model, what's going to happen is you have a decent idea of what kind of things you want to prevent. It's not perfect, but it gives you a good head start. That's the goal of doing threat modeling exercise. Now, the security features. Over here, I'm going to talk about three major pillars: authentication, authorization, and accounting slash auditing. I'm going to call it auditing over here. In authentication, once you start looking at authentication in PostgreSQL, there are two major entry points for the configuration. One is PostgreSQL.conf, the other one is pghva.conf. Both of these files have very different function. PostgreSQL.conf is the default configuration file, but it still contains information that you should definitely look at when you're thinking about security. For example, this is the place where you're going to tell PostgreSQL what are the origins you're going to listen to. What are the addresses that you can listen to? That's the first thing. This is where you also tell your database what kind of connections are allowed and not allowed. You can tell it, you can enable, you should definitely consider enabling SSL. Avoid you. Over here, I'm also going to bring up the best practices. There is another slide for it, but I thought of just putting them anyway. You should start looking at enabling SSL, but that's not enough. There are some vulnerable versions of TLS available already, and you don't want to use them. So you have to disable using TLS 1.0 or 1.1. Then if you're looking at password encryption, what you have to do is not use a weak password encryption. Maybe the data that you're sending is unencrypted, which is what happens when you're using something like MD5 is encrypted, but when you start looking at something like just password as the type, it sends your password in plain text, which is a huge problem. So if you are looking at using password authentication, it's probably a good idea to use Scram SHA 256. This is also the best version available as of now. Then pghva.conf. I don't know how to pronounce this, I'm just going to say conf. Okay, thank you. So over here, this is the file that's actually responsible for setting up the authentication. You can go ahead and define different ways of accessing this application. When I say application, your database. This is what controls the client authentication. Each record is going to tell you what kind of connections are allowed. You need to prevent, you have to ensure that you're not really allowing connections to the Postgres database or the Template databases, because they are incredibly important for your data, for your database, and access to these can lead to some unforeseen situations. So then you start looking at whitelisting the IP addresses that you need. You do that in PostgreSQL.conf. You start looking at the roles and permissions. You should only give the minimum required access, and the documentation tells you what kind of format you have to use. Now, different kind of authentication methods. Now, this is a huge slide. I don't really want to go through all of them, but I can give you some good idea. The ones present here, they trust, password based or certificate. They are either using your passwords or they are looking at using the certificates. If you start looking at LDAP or Radius, they also use your passwords. But I've kept them in the second column primarily because they also need another service to work so that they can do authentication effectively. Trust is when you simply the database simply allows the client to use whatever user they want to use without any password. Password based, you have to put in your username, you have to put in your password. There are three different ways by which you can, there are three different methods of password based authentication. One is Scram, which is hash based. MD5 is also hash based, but Scram is SHA-256, which is much more secure. MD5 is a weaker form of hashing, and it's not exactly something that people still want to use. Password is just plain text, so it's much better that you don't use it. Certificate. If you're working in an enterprise setting, you have already set up a public key infrastructure, then maybe certificate is not a bad idea, because you know exactly who is who. They're using their certificates and things are going to be secure. So there's no sensitive information that's being exchanged anywhere. Now the next part, the authentication methods that need third-party services. GSS API and SSPI are both Kubernetes in the hood. Kubernetes has pretty much been a very safe method of authentication so far. These are the methods that you should consider using in an enterprise setting. LDAP and Radius use passwords. The problem with them is not using the password, but that this password needs to be sent to another server, which means that there are overheads. You have to also ensure that the password that you're going to send, it also goes encrypted, or that network is, or you're using SSL to set up encryption between that network. So every now and then people miss things. So maybe it's much better if you start looking at GSS API or SSPI as methods. Then there are OS-based features. Over here I'm just going to talk about peer. Peer is actually a relatively safer method. This is when you are looking at your operating system user, and based on what operating system user you're logged in as, you're going to access the database. So all the permissions that you get are inherited from this particular user of the operating system. Now, authorization. First I'm going to talk about role-based access control, and the next thing in my plate is row-level security. So yeah, when you start looking at authorization, PostgreSQL has this feature called roles, which is something all of you are probably familiar with. You start thinking about setting access control through those roles. You have users, you have those groups. You set up your permissions, and then you provide those permissions through these database roles to those particular users or groups. Now, these permissions are handled through grant and revoke. If you want to give someone some permission, you use grant. If you want to take away those permissions, you use revoke. A best practice here is to just avoid giving create permissions to public schema, because public schema controls all the objects that can be created. So in case someone has access to public schema, someone has inherited permissions of public schema, they certainly can create database objects, and at times it can lead to unintended circumstances. The next part is it's not just this create issue. There are other things. This was something I was talking about just during the break. Sometimes what can go wrong is some user created a function. Some database user created a function that has to be used by other people. Now the challenge is that these functions have execute permission by default, and if that doesn't look like a problem, there's another step to it. If you're using something like security definer functions, what can happen is these users who are using this security definer function, they can access data that they were not supposed to receive, that they were not supposed to access, because the security definer function runs with permissions of the owner. And I'm going to give you an example. It's a very high level example. I'm hoping that it helps you understand this. Some people in marketing need access to a class. Marketing team needs access to the PIN code of certain users so that they can target ads accordingly. And they asked the security team or the database administrator to provide that access. Now, DBA is like, hey, I'm not going to give you any access. But instead, what I can do is give you access to this particular function. You can use this function, figure out which user lives in what kind of area, so you can target your ads. But but what can go wrong is that they did not really limit their permissions. So the marketing person who was supposed to have access only to certain PIN codes now has access to entire table, so they can even see the customer data, what their phone number is, what their actual name is. It was something that was unexpected. So things like this do come up every now and then. You need to set up some kind of validation. Maybe these people start poking around with that query, and turned out you did not set up any validation on that query. So Now there's a SQL injection coming in from in-house. So another problem. Another best practice, the DB objects or the DB objects that are being created, they should be owned by a role that's well trusted. You should grant your create privilege only to the users who are very well trusted within the company, so that you don't end up in an insider threat situation. Next, row level security. From here I'm gonna rush because I don't have a lot of time, plus I'm gonna be honest, I don't understand some of these things very well. So yeah, authorization, row level security. When you start looking at row level security, the purpose over here is to limit the data, limit visibility of data, or limit access to the data, to certain rows of the data based on who is accessing that data. So if I'm a manager, I should access only my direct reports. I should not be able to access someone else's direct reports. That is the point. You can set up different roles. Each role should have access to different parts of the table. This way you don't have to think about data partitioning or anything else. One of the good things about setting up row level security is that it is deny by default, which means once you have enabled row level security on a certain table, no one can access it unless you specify a policy to a particular role that grants it that access. So this is a great way of setting up setting up some kind of view or providing access to your customers. Now, policies, these are just this is a way to provide permission to select, access, insert, or delete delete rows that match a certain criteria. I just read it. Sorry. Auditing. Now, in auditing, I'm not just going to talk about the database, because auditing is important at every single level. Think about auditing from the application level, at the network level, as well as at the database level and the host files and the host level. So logs are being generated pretty much everywhere. If you're using a Linux server, it's going to generate logs. You can use journalctl for looking at those logs. If you're using your application, you're probably going to generate logs over there. At database level, audit logs are being generated. Now, this one major thing that you have to do is ensure that those logs don't contain any sensitive information, because you don't want your sensitive data to get leaked so quickly. So, prevent sensitive data exposure. How you can do that is maybe you're looking at something like masking your data, or you're thinking about encrypting your data. So, things like this can be done. When you are looking at logging, it's much preferred if you're just logging everything. Don't just leave it at default, because it's going to create problems. In case you think that the logs are insufficient, you can use trigger functions in PostgreSQL to create custom logs. This is not enough. There are two more things that you have to think about. When you're making a query to your database, especially when it's large data, what's going to happen is it's going to create a temporary file, which is something I mentioned earlier. Those temporary files can be accessed by a thread, especially if they have access to the host instance. So you also have to start thinking in terms of how you can prevent those kind of situations from coming up. So you have to continuously review your permissions. You also have to look at who gets to access what. At operating system level, you also have to set up permissions accordingly so that people don't get access to those temporary files or write-ahead log. And the backups, another very important aspect. If you're creating a backup but that backup is in plain text, what can happen is I can simply copy that backup file, recreate that database. But you don't want that to happen. So encrypt your database backups. Now, some interesting extensions. There were 3 extensions that I found interesting. Of these, PJ Crypto is something I've already used earlier in some side project that I did. PG Audit works on top of existing PostgreSQL functionality, logging functionality. You can use this extension to set up object level and session level logging. What you can do is, what you can use it for is, in case you have any sort of compliance requirements or regulatory requirements, you can use this extension to make your job easier. You can try doing it by yourself, set up your manual triggers and all, but that's going to be a bit hectic. So you can use this particular extension, make things easier. But but again, a catch. You still have to ensure that your logs are not logging any sensitive information. PG Crypto. PG Crypto is an extension that allows you to use that allows you access to some functions, some cryptographic functions. If you want to hash something at database level, you can use PG Crypto. If you want to encrypt something, you can still use PG Crypto. The only downside that I think about this extension is that the functions are running in the server, those cryptographic functions, not your database functions this time. Your functions are running in the server, and what this means is that the data, the sensitive data that's being created, that is accessible in that server, even if it's for a short time. So think about it. Most of the times it's an acceptable level of risk. You can assume that this should be fine and go ahead with things. But yeah, in case you have very sensitive data, you might need to rethink of your approaches as well. Next, auth delay. Auth delay was a very interesting extension I found, primarily because it tries to prevent brute force attempts in a manner. What happens is that in case you tried doing some kind of authentication and that failed, auth delay is going to intentionally create a small lag between you and the server so that you can avoid brute forcing your attempts. But one of the catches over here is that even if it's saying you cannot authenticate to the server, what's there to prevent auth delay from, if you have a connection pool, you can simply keep sending requests with different usernames and passwords. Now that's a much bigger issue. So it's not going to prevent denial of service, but it is a reasonably good attempt at preventing brute force attacks. So this is my last slide, best practices. I miss a lot of things, I'm gonna accept, but this is primarily focused at that threat modeling thing I had mentioned earlier. So, some of the best practices: ensure that your database instance is not exposed to internet. And the reason it's at top is that DeepSeek accidentally ended up doing it. You have to look at setting up least privileges for each role. Do not give more permission than what is required. A lot of times what you will notice is within your own enterprise, people will have more permission than they actually want. Sometimes people are just admins. Don't do that with your database, because now the data is going to be very sensitive. So try keeping the permissions and privileges to a minimum. Encrypt your backups. You also start thinking about encrypting your data not just in REST, which is at the file system level, but also in transit. Because when you're sending your data, in case there's some kind of network sniffing happening, you also have to prevent them from looking at your data. So encryption at REST, encryption at transit. This is not just at the database level. Think about it from the application level, because when you are sending that data, you are also sending some kind of sensitive information. Maybe it's a good idea to encrypt that data right there and then send over. So, and start thinking about encryption at application level. Maybe it's a great idea, maybe it's not. It depends on your use case. Revoke the create privileges from public schema. It's important to avoid some random user from creating some things that you don't expect there. Log as much as possible everywhere at all the different parameters, at the user level, at the application level, network, host operating system, everywhere. Try logging in as much as possible. A downside to this is that it's going to create a lot of noise. But in the longer run, when you start looking at auditing, it's incredibly important and useful. Then you also must regularly update your database as well as the operating system. because operating system contains hundreds of packages, and in case one has a vulnerability, you don't want that vulnerability to affect your database, especially if there's a dependency. Generally it might not really be the case, but in case there's a dependency of your PostgreSQL, then suddenly it's a huge problem. Then revoke updates on columns that should not be updated. In case you are looking at a column like last updated app, do you really want it to get updated? Think about it, revoke privileges wherever needed, and set up data obfuscation or masking when you start thinking about logging. So yeah, this is it from my end. In case you have any questions, please feel free to ask me. I can't guarantee answering everything, but I can surely give it a shot.
Yeah, is there any vulnerability tool to identify the vulnerabilities in the PostgreSQL? The recommended vulnerability tool?
So far, I don't know of any vulnerability, any tool that can identify vulnerability in PostgreSQL. What you can look at is if there's any official notification coming in on vulnerabilities. In case there's any there's any serious vulnerability, you're probably gonna notice it, because PostgreSQL also puts it out, makes announcements for it.
Okay. So, is PostgreSQL compliant to any of the security compliances like PCI DSS, HIPAA by default?
Nope. From what I notice, it's not. You will probably need to set it up.
Oh, okay.
Yeah, you can probably look at auditing and other things, look at extensions, but last time I was working on this, last time I was looking at this, I did not see anything that can make PostgreSQL compliant automatically. In case it is, maybe it would be great if you can tell me as well.
Yeah, even I'm just listening for the first time on the PostgreSQL.
Okay.
Okay, so given a column, I want to encrypt a column, but I want to ensure that even the database administrator will not be able to view the contents. Is this possible?
Yes, that is what that is when you can use something like PG crypto, because what's going to happen is you can't really trust anyone.
Not a third party tool. Feature on the table or the column itself. Where simply I select the column, right click, and then I want to encrypt it.
Okay.
Once I encrypt it, administrator should also not be able to see, only the application. In the application I want to see the data. Is it possible?
Not at PostgreSQL level. You'll have to set up encryption at your application level.
Okay.
Yeah.
So, okay, fine. So, regarding masking you were talking, right? So, what is how we'll do masking in PostgreSQL?
So, I had written function manually which would only reveal the first four letters and pretty much send everything else as access. You can do it at your application level as well, but I don't know if there's any extension available. I know that there are enterprise solutions that can do this, but for doing this yourself,
there is no support for masking in the PostgreSQL, you're saying?
Not directly. There's another extension called PG Anonymizer, if I remember correctly, which allows you to mask. But there's no inbuilt access. There's no inbuilt functionality as of now.
Okay. Yeah. So and PostgreSQL actually in coordination with this, meaning will it work for all these cloud environments today? All the three GCP can we use PostgreSQL so within the cloud or not possible?
Yeah, obviously you can use it. Even all of these major cloud providers, all of these cloud providers also give you PostgreSQL as a service. So yeah, that is definitely possible. So in Google Cloud, it's called Google Cloud SQL. I don't know if there's something similar in AWS, but you can definitely host your PostgreSQL instance. RDS is there, yeah. But RDS is not PostgreSQL underneath, right? It is Postgres. Okay. So there is Amazon RDS as well. Thank you.
Okay. Maybe last questions. Sorry, so many questions. See, whatever attacks happened on PostgreSQL, Generally, that will be your proprietary data. So can you share that data to me? Is it possible like that?
Sorry, I didn't get your question. Can you please
No,
help me understand?
whatever attacks, whatever hacks or attacks happened on the PostgreSQL, you may maintain a database, right?
Yeah.
Okay, somewhere you will be maintaining the database of what kind of attacks so far happened on the PostgreSQL.
Yeah.
So is it possible to share that database with me?
Oh, you want me to share what kind of attacks happened in my enterprise setting with you? Am I understanding your question correctly?
No, what I...
Even in the case you're asking me, I did not maintain that list actually.
No, it will be there in the, because it's an organization, since maybe last 5 years, 10 years data will be there, where some attacks were already happened all over the world using this PostgreSQL, right? Such database and all you will maintain, right? So what kind of attack then, so that we can actually fix a head, right? If you use this DB, we'll fix a head or configure it properly so that that kind of an attack will not happen. If you can able to share that data, generally it will be proprietary. I should not ask you.
So I'm going to be honest, I never maintained that kind of list. But there is an incident that I can share. I don't know if I'm supposed to share it though. I mean, it's been a while. It has already been patched, so I don't think it's going to be a problem. Once I noticed that some people had accidentally exposed their database which contained KYC information. So people could just go ahead and download those files where it was some sensitive data, something like Aadhaar, you can say. It was not Aadhaar though, I'm just taking it as an example. But every now and then these things happen. In case you are looking specifically at attacks that can happen on DBs, a lot of places maintain those lists. I remember there is a company called Wiz which has that list on threats and the attacks. Maybe you can check that out. I don't really have the link as of now. But yeah, it should be a search away. Then you can look at CVs, because a lot of CVs also give you information on what kind of attacks happen. So I think that should be useful.
Yeah, that way actually I can get the detail. Okay, fine, sure. Yeah, if the CV is not raised, maybe I'm saying it's a publicly known CV is raised, I can find a CV, but some kind of, anyway, that's fine. Thanks for answering all these questions.
Thank you. Okay, is there any other question? Alright, I'm gonna say there's no other question. So thank you so much everyone. And in case you have any feedback, please let me know.
Thank you.